Year 13 A-level chemists. Let's look at some reactions of benzene and a focus on nitration, but specifically where nitration is kind of hidden within the question. Because it's all well and good if they just say benzene is giving you nitrobenzene, but here we're going to map out the synthetic route if we're going from benzene to this over here. Oh my gosh, what is that called? N-phenyl ethanamide, right? So an amide. And you might not spot the nitration straight away, but as soon as you see a nitrogen, did I say that sounded weird, a nitrogen attached to your benzene ring, it must have got there through the process of nitration for the, extent of A-level chemistry anyway. So we can work backwards in our retrosynthesis to see how we got from here, to here, and then maybe we meet somewhere in the middle. Because we have got an amide. We know that amides are formed from, say it with me, from my organic synthesis video, acyl chlorides and amines. So this must have come from a bond being formed here in a condensation reaction between our amine phenylamine, so with an NH2 here, and this would have been our ethanoyl chloride. I'm going to draw it upside down just so you can see exactly where it came from, and then maybe I'll draw it the right way up afterwards so it looks less scary. Okay, ethanoyl chloride, which is the same, oh gosh, as this. Okay. So now, how did we get this amine? Again, now we can maybe meet somewhere in the middle because we know in order to get this nitrogen, this came from a nitrobenzene. And in order to nitrate your benzene, your reagents are going to be concentrated nitric acid and concentrated sulfuric acid. That's going to give us our nitrobenzene. How many times can I say nitrobenzene? Through the only mechanism that we know for benzene, which is an oh, I don't like that. No. Which is through an electrophilic substitution reaction. In terms of what that looks like as a mechanism, that video exists, right? At least on TikTok, maybe I'll make a YouTube of it as well. Electrophilic substitution to get our NO2 onto here. Now, our next question is, how do we get from our NO2 to our NH2? That relies on our understanding from the amines topic, and I definitely have made that video on YouTube, where we have gone from having oxygens on this nitrogen to hydrogens on this nitrogen. Now, it's a really, really common mistake for students to go, oh, well, clearly, I'll just add ammonia and swap the NO2 for the NH2. But if that's the case, what was the point? What was the point of doing all of this work to get this nitrogen onto the benzene if you're now just going to swap it for a different nitrogen on ammonia? We put that nitrogen there for a reason. That nitrogen is staying. It's staying. And you're going to love me. Okay, and so all we're doing is we're essentially swapping these oxygens for these hydrogens. So if we're losing oxygen or gaining hydrogen, that of course is a reduction reaction. And the reagents and conditions for that, the reducing agent that we use is a reducing agent that we only see here in the course and nowhere else really. And that is tin and HCl. Okay, that's going to reduce our nitrobenzene to our phenylamine or aminobenzene, depending on what you're reading. And then this will react with our acyl chloride in acyl chlorides, there's only one mechanism that we know for acyl chlorides, and that is nucleophilic addition elimination. And we go from our amine to our amides. Let's label these groups. So we've gone from benzene to nitrobenzene to an amine, reacting that with an acyl chloride. So that would be our reagent. Let me put it on the arrow. Ethanoyl chloride to give us our amide. Okay, so all of that to say, if you see a nitrogen on your benzene, it came from nitrobenzene. And then you can use your typical kind of aliphatic chemistry or usual organic synthetic routes to figure out how you got whatever else it is on there. That wasn't too bad. Make sure that you like, sorry, I mean, it was great. Yay. Make sure that you like, comment, and subscribe. And for more A-level chemistry support, I will see you in my next video.